Hello again, Mark. So we did an intro to Tintri and the changes since the last set of videos we did, and we talked through some of the things in a little bit, basic detail. Now let's dig down a little bit more. So one of the things is TGC's changed quite a lot, and also there's been some introduction for scale out in that. So tell us a little bit more about those features and functions.
Yeah, so Tintri Global Center has evolved considerably, as I mentioned in the previous introduction that we did. I mean, it's evolved from being a monitoring and management platform to a configuration management platform too. So we have the ability to set policies on a per VM or grouping of VM basis, so we call that a service group. So you could set your policies such as snapshot schedules, replication schedules, even quality of service policies, so you can find all the VMs that have SQL in the name, and then you can set appropriate minimum maximum performance guarantees. But what we've most recently introduced is the ability to load balance virtual machines across pools of Tintri devices, and it works across different hypervisor types. So by way of example, we could have a pool of Tintri VM stores, and the pool could contain both hybrid flash or all flash, and it could be any generation of Tintri products. So if you'd have purchased a T540 from a few years back, and now you're running the T800 series or the T5000 all-flash family, the load balancing capability is intelligent enough to understand the capabilities of each of those devices and make appropriate recommendations on where your virtual machine should live. Now, the kinds of things we take into account when making recommendations is basically, obviously, capacity related information. So we will tell you, we can see that your environment is growing by a specific rate per day, and what the likelihood is that you're going to run out of space in a given time frame, and from that we can say we recommend you move a bunch of virtual machines from one Tintri device to another Tintri device, at which point you have some options available to you. You can do the migration there and then, so you can accept the recommendation. You can defer the recommendation to a later time point. You can choose to not move specific VMs, so you can set affinity rules around that. So for example, if you've got a very large Exchange database or SQL database, you may want to keep that on a specific device, so you can set those appropriate affinity rules. And then basically what we do is we leverage storage vMotion rather under the covers to move those virtual machines from one Tintri device to another. But what we do is we preserve all of the information and policy around those virtual machines. So the history is maintained, so you can look at all the statistics about that virtual machine, even though it's now living in a different location. But the policy is sticky, so if you set snapshot schedules, replication, if you set quality of service, they're retained even on the destination VM store where that VM now resides. And we also have the intelligence to move snapshots. So snapshot data is moved along with those virtual machines. So it's a pretty intelligent capability that we've introduced.
So it's quite different to storage DRS then, because that would just move the machine itself and none of the history and things.
So it's very different to storage DRS. I mean, storage DRS in itself really uses two main parameters: the capacity on a data store, and also the latency of a data store. But the problem with the latency measurement is the minimum level that storage DRS measures to is 5 milliseconds. Now, whether you're running hybrid flash or all flash, the likelihood is you're servicing I/O 1 millisecond or way less than that. Yeah. So storage DRS isn't necessarily the most useful capability to determine where virtual machines should live. Now, in the case of Tintri VM scale out, because we have very rich information, very detailed analytics around how each virtual machine is interacting with the storage, we can make far more intelligent decisions. And we can also take into account policies that you may have set. So for example, if you specified the minimum quality of service for a whole bunch of VMs on a Tintri VM store, and you've oversubscribed the minimum capabilities of that device, you'll get a recommendation that says, move a bunch of VMs to a different appliance. And by doing so, you will free up your performance, your IOPS on the source VM store by a given amount. And again, you can choose to migrate those VMs there and then at a later time point, or set your affinity rules appropriately to not move certain VMs.
So that's going to make the storage guys' world a lot easier, or the VMware administrator's job a lot easier in the future.
Absolutely. I mean, much of what we're trying to achieve here is not just the simplicity of understanding where virtual machines should live, but actually from a customer perspective, we want to be able to drive the efficiency levels that they can get out of their storage. So if a VM should live on an all-flash array, we can make that recommendation. If it's happily living on a hybrid flash array, we can make the appropriate recommendations there. But the key thing here is, whatever devices you have in the pool, we will allow you to achieve the most efficient use of those resources.
Okay, thank you very much, Mark.
Thank you.